Hi, welcome to UTA Planetarium Sky Update. My name is Levent Gürdemir, UTA Planetarium Director and Astronomer, and here Jim Bader, Program Coordinator of the Planetarium. Hi,
Hey,
Jim.
how's it going? It's a beautiful day outside today. It's sunny. It's warm.
It is,
Um, Huge fan. Seasonally, this is not normal, but it feels good, right?
yeah, it is unlike the last December, right? We had
Yeah.
all the cold weather, minus Fahrenheit degrees. It was terrible.
Yeah, I was checking social media to make sure there's no news updates, and I was even seeing people in places like Denver, which typically this time of the year got a lot of snow on the ground, and they're saying, "Hey, there's no snow here. It's hot outside. It's not even sweater weather." It's wild to me.
Yeah,
But
let's take the advantage of these warm weather.
I do want to say that I if I had to choose sunny and 70 over like 40 and miserable looking, I'm gonna choose sunny and 70 every time. I can go for a walk and feel great, not have to wear a bunch of sweaters.
You know, they say it's always barbecue time in Texas.
It surely is today. Lamia says hello. Hello, Lamia. Good to see you in the
Hi,
stream.
Lamia. Good to see you again.
Sorry we're late. We had a
Technical problem.
little hiccup.
All right. So, what are we answering today, Jim?
Well, we have
Any
we
news?
want to
Any
talk
good
about.
news coming up?
Yeah, there was a news article. Can I cut in right before we get to the news article? Can I mention
Absolutely.
that
Yeah.
tomorrow is exciting. I know we've said it so many times,
Mhm.
but tomorrow at 1 p.m. we open the planetarium for the first time in
2 years, almost.
it feels crazy. It's been so long. Ugh.
It has been, yes. Finally, planetarium resumes public shows, in-person ones tomorrow. We have a great show schedules for Saturdays, and if you're wondering what Planetarium is doing during the weekdays, we are getting field trips, K through 12 people, plus astronomy classes at the both undergraduate and graduate level happening in the planetarium. And we offer our planetarium over the weekends for public showings. And tomorrow, 1 o'clock, Big Bird show, an Elmo show, will start One World, One Sky. And then the remaining of the schedule you can find on our website. Check utaplanetarium.com for further information and come visit us.
Yep. All right. Okay, now, Levin, we've got to the point. Are you ready for me to show you the news update for today?
Yes, let's see what's in the news. News today.
All right. We got sent this by a colleague, and we thought it was important. I think it's important that we talk about it because there's also something really relevant to it. So take it away, I guess.
Football field sized asteroid to approach Earth on Monday night, one of several in the coming weeks. So, are we in danger? Are we going to die? We'll answer those questions. Well, in fact, I didn't find this article very interesting because the reason is we'll talk about that. But I need to mention I saw several headlines in the different news media, and they were talking about pretty much they were wording it like the same way. You know, it's a big one, football field size. Yeah, football field is big for us. If you are watching something from the near the football field, it's a huge thing, right? And you imagine that something like that coming in space always scary. When I think
Just
about the
can I add to what you said real
yeah,
quick? Just a small tidbit. You said they were saying how big it was. Um, Before it says any more facts, like before it just says, "Hey, there's this football size asteroid," and if it impacted us, it said it would be an explosion similar to 77 megatons of TNT.
Mhm.
For reference, the Tsar Bomba, which is Russia's I think it's the largest atomic explosion ever
Yeah,
on Earth. Um, was equivalent of 57. So this is 20 more megatons than the Tsar Bomba. And just this sounds so scary. Okay, now continue where you're going because I think I know where you're headed.
But still, it is not large enough or big enough to affect or cause major effect on the planet itself. Well, the if you remember the Arizona crater, the crater in Arizona, it was formed 50,000 years ago, and the size of the asteroid thought to be the lengthwise, it was similar to a 767 jet. So 767 is a long jet. If I remember correctly, it is about 150 feet. So that was the size of asteroid. So if that impacts Earth, of course, we are thinking about head-on collision. It doesn't have to be head-on. It may be almost like a side-swipe one, which the most of the energy is used to divert the asteroid, and of course, it would just cause slight damage on the crust of the planet, or maybe to tsunamis if it is touching on or the contact is made by the ocean. Yeah, if it was a head-on collision, we can calculate because we know the mass of Earth, we know the mass of the asteroid, and we can also convert that a bomb, how many kilos or tons of bombs you need to use to produce similar energy. But after all, I mean, this is not very important because the reason is it's coming to Earth, but it's not going to collide with Earth. They say it's getting close. Maybe. Let's think about how close is this. So the news said, or the article said, it is going to pass by 3.8 million kilometers away. So roughly, for simplicity, I'm gonna do big rounding over here. It is about 2.5 million miles. So how far is 2.5 million miles? In space, you think it's not a big distance because even to express numbers, we most of the time use astronomical units, and especially with the distances of stars, we are using another terms like parsecs, light years, for example. But if you think about something near Earth, the moon distance. The moon is not, I mean, the closest object to us, but of course, you know, it's still there's a big gap between Earth and the moon is 250,000 miles away. So 250,000 miles, and this object is 2.5 million miles. There's a 10 times difference. That means this football field size object is going to be traveling at the closest 10 times the Earth-Moon distance. And if you look at this scenario from space, imagine Earth, planet, and the moon somewhere around it, and a 10 times farther, a football field is just traveling.
I have a good representation. I think I'm going to be able to do this. So.
Would you really care about this?
That's like somebody throwing a football in the Walmart parking lot when you're in the AT&T Stadium.
And especially, this is not a surprising event because, you know, we know the Earth orbit is not cleared. When we talk about the formation of solar system, we say, you know, the Earth was, the solar system was more crowded in the past. Because there was a lot of debris because of the early collisions and the formed and unformed planets. But this one, you know, by the evolution of the solar system, the planets, while they are orbiting, they are clearing their orbit. Or the Earth's orbit is not completely cleared, so there's still debris. That's why we have meteor showers. And here is Jim's representation.
This is the Earth and the Moon.
Right. So.
And that's the accurate distance.
Mm-hmm.
And
the object would be
probably off screen.
Off the screen. Okay.
I mean, if I zoomed out anymore,
imagine Earth. I mean, it is scaled to a so distance that we cannot even see the Earth great. But imagine if this is the size of Earth, Moon is certainly smaller than that. So this is the Earth Moon distance. So our object, our football field, is flying off the screen.
Okay,
I
real
mean, this is.
question.
I mean, this is okay. This may be astronomically significant event, not very significant, but has a significance. But it is not going to impact. It is not threatening anything, and it is not rare either. Because I am afraid
Yeah.
that some news will start talking about like this is rare. This never happened a million years
This article
before.
from USA Today said stuff like
Mhm.
that. It isn't. I mean,
Yeah,
I don't know, but it's worded in strange ways.
yeah.
And, we had
But
some. Go ahead.
if the article said, well, there is an object regardless of the size, football field or school bus size, satellite size, you name it. It is going to come close to Earth, and according to our calculations, potentially it will collide. What we would do?
We have solutions. Well, we might have a solution. Before we get to the solution,
we?
if it's okay with you, let's just hop in. We have Brexton finally joined us on YouTube. Brexton, good to see you on YouTube.
Good to see you, Braxton.
Brexton says, "I think this is the question that he's talked about before," and then he seems disappointed by saying, "So not another crater to visit?"
No.
No. If it did hit us, I'm not even sure if it would leave much of a crater.
Yeah, I
Maybe
mean,
it would. I don't know.
Arizona crater is, I think it is the last crater that is identifiable as a like a result of
It's
big
yeah,
impact.
it is a very recent one.
There may be small impacts. Maybe I don't know if there was a crater found at the Tunguska plant in Russia.
I think just a lot of flat trees.
Yeah, but that was also thought to be a large object falling from sky. But that object, to our understanding, is it did not fell into ground and impact. It exploded in the air and completely evaporated. And all the trees were knocked down because of the shock wave released as a result of the explosion.
Yep.
So this is what we think what happened with the Tunguska.
Then yeah, Brexton says something that I think USA Today was trying to infer, that maybe his comment is, could we watch it in a telescope?
Well, it is visible at one point in the sky, and if you have dark sky conditions and the good size of a telescope, yes, you can watch it. I didn't check what was the brightest magnitude it comes.
Couldn't find anything about
But
it.
certainly, I mean, it was detected with a telescope, ground-based telescope. So I presumably you can see it with a good size of telescope from a good location.
Yeah, it
Dallas
says
is not a good.
only thing I could find said that California residents would be able to see the asteroid with a telescope from 4:30 p.m. to 5 p.m.,
Mhm.
which I'm sure you realize it's probably not very dark yet. So
California resident.
yeah, I don't know. And the article is reporting from Sacramento, so that's probably why. I don't know. What do we do, Levin? How do we protect ourselves?
Is there a way to protect it if something is coming from space?
Maybe.
That's always a question, and that question was
I know what we do. We hire a bunch of oil people who are drillers. We teach them how to be astronauts, launch them to space with an atomic bomb. They drill down into the asteroid. They blow it up. You could probably make a movie off that. Actually, I should sell those as movie.
yeah. I mean, you can certainly explode in an asteroid. The problem you will be dealing afterwards is after the explosion, the asteroid will be broken into a lot of debris, which still carrying mass and gravity, and that debris can come into Earth and still enter into atmosphere, and rather than one big piece of body is hitting Earth, millions or maybe trillions of debris maybe just going into the collision with Earth.
But
So explosion is not going to solve the problem.
what's so wild about that, right, is you're not necessarily reducing the mass at all, right?
No, you are just
Some of it might be ejected away from the directive head, but all you're really doing is just changing the vector, right?
I mean,
so
if you imagine like a two-car accident, okay, so you are thinking that, well, that car is going to hit my car, but I would prefer, rather than that car is hitting my car in one piece, I can just break into the pieces, like all the wheels and steering wheel and all the pieces you can come up with from the car. They can individually hit my car. So not much difference is gonna make for sure.
definitely, I think it's really hard to imagine on Earth because of the speeds we deal with and the momentums we deal with,
Yeah.
and even the inertia. I mean, an asteroid is so big and moving at such an insane speed that if you hit it with an explosion and slow it down when it's close to Earth, it's too late. I mean, you slow it down, it's not going to be enough. Still, like you said, it's going to be like a pile of knives coming at you instead of a big hammer.
Yeah, the most critical thing about asteroid impacts is the angle of the collision, because what we call head-on collision is the asteroid directly comes and slams on the ground at 90 degrees, almost like free falling from the sky. So this is the most dangerous part, because this is when most energy transmitted to Earth's surface. But the angle is greater than like this one, for example. If the angle is greater,
I got ahead of myself here. Sorry.
in this case, the only part of the energy will be transferred to the crust of Earth, and the rest of the energy will be used to, again, divert this, like bounce it back to the space. So in this case, the amount of the energy transfer will be less. It can be even sideswiped, like for example, for the formation of moon. So our theories come up to one point that it was probably formed after a giant object, and maybe Mars-sized planet, sideswiped the Earth and took chunk from the surface, from the crust, and just threw it in space. So this is pretty much likely to what happened when an asteroid comes, and that's how actually the asteroids from Mars and asteroids from Moon is end up in Earth as an asteroid or meteor. So when you look at some of the meteors, the chemical composition, we can see that, oh, this meteor is actually coming from the moon, this asteroid is actually coming from Mars. But think about it, like how a rock resting on the surface of the moon or resting on the surface of Mars ending up at Earth.
Definitely.
All right.
Okay.
I think,
to hurry this along,
we have something else to explain, right?
let's talk about, you could technically hit it with something even small, right, and change its momentum, its speed, its velocity. And if you did it just enough, and you did it early enough, it might be enough for it to miss Earth altogether, right? That's the idea of our solution.
Is that how they really called it, double asteroid redirection test?
Yeah.
Yeah, I always think they first come up with the acronyms, and then they figure out what the actual words is gonna be. But this
is too relevant,
because the thing is, I'm looking at myself on the screen and I see darts, and first thing I came up with, like, what is the Dallas area rapid transportation have to do with my talk? Because all of the buses in Dallas, they have that dart symbol or logo.
Before you brought up the Dallas area rapid transit, Brexton commented, does Dart rail run close to your skull?
So I'm not the only one, as you see, coming up with.
No, for Dallas residents, it's a very it's awkward to see that acronym used for something else. But yeah.
Okay, so what is our best solution? If we have an asteroid coming up and we were able to detect it early, how can we protect our planet from a collision and we may not end up as like dinosaurs?
Well, the solution is DART. They're going to take a tiny little spacecraft,
Uh-huh.
fly it at a pretty incredible speed,
Mhm.
and smack it into the surface and find out what happens. But this is a really basic physics problem, right? I
Yeah.
mean, you have, hey, I have this energy, I have this energy, then I know the answer energy because you add them together.
Yeah, pretty much like playing pool, right?
Yeah, but
You just
why
you
are they
have a
doing
ball
this then?
rolling to you, and you just use another ball, and you push it with an angle, or your ball that you throw is colliding in an angle that other ball, which was originally approaching to you, will be diverted. Its path is going to be diverted to another place. So that's one way, and I think also there is another way, which is a similar one. We had lately in the last 20 decades very successful asteroid missions. So we had asteroid landers, satellites, and especially the famous European Space Agency mission Philae and Rosetta. They landed on the surface of an asteroid. So after they landed, they can pretty much like capture the asteroid and maybe like fire some propulsion engines and drift away the asteroid. So that's also another possibility that they can do.
Well, DART is a part of NASA's, it's called the Planetary Defense Coordination Office, or Planetary Defense Force.
Wow, Planetary Defense Coordination.
Sounds exciting.
So if you are
And that's
working in that
along with
office, you are Planetary Defense Officer.
yeah, what an epic title. That's along with other things like what you're talking about. There's more missions along those lines. With similar missions where they went to asteroids, though, they started to discover that, hey, asteroids are not really like a solid piece. Some of them are a little more sandier than others. Some of them are a little more rocky. And I mean, when you have, we're going to say, pool ball A and pool ball B, and they hit each other, as long as no mass is lost, the energy outcome is exactly what you could calculate. I mean, in a vacuum, right? And even on a pool table, realistically, it's pretty close, really, really close. But if the pool ball breaks, it's not equal, right?
Yeah, imagine instead of you are
lose
using
mass, right?
yeah, imagine if you are using instead of pool table balls, you are using eggs.
Something like eggs.
You are changing the dynamics completely because when they collide with each other, or the egg is rolling to you on the pool table and you are trying to divert it with your ball. Your ball is a solid object, egg is not. So yeah, that is completely different collision, which energy transfer is not done 100%.
And that's what DART is going to test. Is we know there's going to be ejecta in almost any case. So let's hit an asteroid, see how much it ejects. This DART has got a. If I hide myself, you can see a little tiny robot next to it, a little spacecraft. This little spacecraft is going to fly over the impact and just take as many pictures as it can take.
Yeah.
And this way, I mean, if this works and it works well as we expect it to, it means as long as we have 5 years notice, we can save ourselves from an asteroid impact.
Yeah.
But we need a lot of time.
Yeah. My question would be here is, well, usually the missions that takes place in space, as we briefly mentioned last time, it takes a long time. It takes sometimes a decade to calculate, design, manufacture, find the right launch date, and test it 10 times before you launch. Will that DARTS Institute have enough time
Exactly.
to get ready to do a mission like that and successfully accomplish it.
Well, I mean, I still would say I'd rather know that we have some form of protection, at least against some of them, than nothing, right? I think that's minimum. I do want to just say that Lamia asked some questions, which I was hoping we kind of answered. One of them was, she just called out what we were talking about, Dart mission. She said, I remember reading something about hitting an object with a force enough to change its direction. That's kind of sort of what we're talking about. That's kind of sort of what Dart's doing. A little more complicated than that, but true. And then her question was, well, what is the expected damage in such an incident, similar to if that football field hit the earth?
Yeah.
Um,
Well, again, the main parameter we need to know is the angle it's coming to Earth. If it's a head-on collision, different story. Side swipe, different story, and also an angle in between is a different story. But even in the first or the worst case, it would be head-on collision, which the object would straight fall from the sky. It depends on where exactly it is hitting on. Like if it hits in the middle of Antarctica, we would probably don't care much because yeah, it will create something like maybe in a bigger scale a Tunguska event at Russia. Look at the you can find the pictures on the internet. There was a strange area with the Tunguska event that the trees were completely flattened in a big large area. So again, what we think is probably the asteroid exploded in the air and caused the released shock wave after the explosion caused all the trees to be flattened. The most dangerous part is if it falls onto an ocean. There is not an immediate threat for the oceanic events, but they create big waves. So anything falls into ocean from space, they are not going to immediately cause any problem on the surface of Earth. The ocean will handle well, pretty well, but it will create big waves, will turn into tsunamis, and those two tsunamis will end up somewhere on the shores. So the shores of nearby or the closest countries may be flooded, or if it's a big enough, it may flood actually a big area. Maybe sometimes half of a continent or maybe an entire country can go underwater immediately with those big tsunamis.
some of
If
those
the
small
asteroid
countries.
is big enough like this. But yeah, it can cause a big problem.
Okay, so last thing before we go, just because Brexton was really on fire with these, and I have to say they're funny, I'm gonna let you read them, Levent. This was his first comment in response to your description. You can read that, right?
That's a extraterrestrial information. That's
Exactly.
exactly what I thought. Okay, exactly.
All right, how ridiculous. So, either way, it's interesting. We'll know. This is supposed to hit the asteroid in 2022 or near 2023. I think September of 2022 is what they expected.
Yeah, I
But
mean asteroids come all the time, and
yeah,
also they are on the Earth's orbit already. That's why, as I said, we are having meteor showers. If the Earth's orbit was completely clear, we didn't have meteor showers. Well, the small asteroids, most of them are small enough to not to cause any danger. Our Earth's air atmosphere is the protective shield for them, because atmosphere likes burning these in the sky.
Yeah.
So it gives us fireworks. We call them shooting stars. But time to time, yeah, we encounter these big particles. Well, statistically, the collision probability is very low, because Earth is a moving object on its orbit, and there's things fly in the solar system, but two different bodies come into the intersection. There's a chance, but the chance is not very concerning. So for that reason, there is not much concern because of these events. But of course, like the Dart Institute is doing, we should always get some type of preparation in case anything comes from space. We are ready to divert it, not explode it, divert it.
So, should we be scared of asteroid impactors? Last thing before we leave.
Well, I wouldn't immediately scare, because again, I mean, the probability is low. But also we should have some, engineering plans in place in case one comes threatening. We at least know what to do.
All right, that's it for this
All right.
week.
We'll be on Facebook Wednesday, and Fridays are YouTube times. So we'll certainly see you next week.
All right.
Have a great
See you later,
weekend.
everybody.